Hi everyone, welcome back to this channel. Finally, I got back my FieldFox after delay for a month in the shipment. Right now we can revisit some of the features that can be found on the FieldFox. So today I'm going to focus on noise figure measurements. As you can see on the left side is the FieldFox display. On the right side is spectrum analyzer display, so that we can do a comparison between noise figure measurements using two different instruments. So this is my setup right now on the FieldFox. So this is where the remote desktop that you're seeing on the screen is connected to the FieldFox from my PC, and this is the output of the DC to control the noise source. So just plug in a SMB cable here, and for the noise source you can just use the 346 model. This is my amplifier under test, and it's connected to this power supply. Just a simple setup. And this is the spectrum analyzer that we're going to compare to the measurements. So I'm going to test on both this input and calibrations and whatnot. I'm going to show you step by step on how to run the calibrations, the setup from both FieldFox and also the spectrum analyzer. I'm going to start using the FieldFox as a measurements tool. So let's go to mode and go to more and look for the noise figure. So noise figure should be here, and let's preset this. So noise figure and F. If you choose from mode, this is how it will look like. So let's go back to mode, more noise figure, and this is how it looks like, the default screen. So from there you have to set up a couple of things, such as the physical setup with the DC output to control the noise source. Once that's done, then we can set up over here the start-stop frequency. Let's change the start to 1.04 gig and the start 1.49 gig. So this is the best working area for my amplifier under test. So let's do that, start-stop, and I'll change the resolution bandwidth to 300 kHz. So that it's tallied to what the spectrum analyzer has. The next thing you want to do is to key in the noise table that you found on your noise source, because this type of noise source is not the smart noise source that has the ROM built in, so you have to key in manually. So how do we do it? Just go to measurement setup, noise source, noise mode table, edit ENR table. This is where you key in the serial number, the model number, so that you can recall what you have done, which model are you using. So this is where you're going to set up, and this is what I've done. And if you need to add in a row, just click in a row here. Let's say we want to change it to 4 GHz, and 4 GHz it's 20.08 dB. So as simple as that, done. And if you want to add in more information such as the uncertainty, so you can actually change here and on and off row. So this is on and off impedance. You can just do that. And once you're done, just click back. And that's it. As simple as that. And the other one is you can declare what type of dot you are doing, or you can just leave it as it is. You can add some information here, so for example, the frequency range that it's working on. So it's just another way to input the setup. Integrations, I won't change anything here, so these are by default. You can change the scan time. If you have a charging circuit, then you might want to do a delay over here. Just put longer wait time, delay time, so that your circuit is more stable. Uncertainty, again, this is just a calculations. You can just add in everything here, and then it will show you the end result. We won't go through that because I don't have all these informations with me. Again, the main focus for this video is just to teach you how to set up, and then in detail you can actually read through the help file, the guide, or you call the local keyside support. So resolution bandwidth, we have done that. We have in the ENR table, and yeah, it's ready to go. So we go to cal. So for a receiver cal, it's actually a direct connections here. So for our case, it's similar between the receiver cal and also user cal, because Sometimes you want to add in extra amplifier preamp to make your noise form works better. So that's where the user count comes in. But for our case here, because our amplifier is the device on the task, so we don't have any other bits and pieces, preamp and attenuator along the path. So I'm going to do that right now. As the picture show, noise source directly to port 2. As you can see on the picture, I connected the noise source directly to port 2 with an adapter. Yes, we have to characterize the adapter if you want a more accurate amplitude measurements, but for now, this is how it looks like. Let's click measure. Let's go through that. Once it's done, just click done, and there you go. And before that, we want to have two traces. One is noise figure, the other one is gain. So by default, this is how it looks like, noise figure and gain at the bottom. Let's turn on the marker right in the middle of that frequency band, and this is how it looks like. And you can do auto scale. So auto scale all, this is what it looks like. So this is part of the system measurement. And right now you can run a user count if you want to get a more accurate information. If you have a preamp in the middle of the measurements and after the preamp is your device on the task, then we do recommend to do this. If you have a long cable in replacing this preamp, yes, we might want to do this also to get more accurate measurements. Anyway, let's do a measurements right now without changing anything like what you're seeing previously. So you notice that the measurement is flatter. Let's do an auto scale right now. So it's roughly that. Yeah, this could be some connection issue, but it's not that huge of the measurements. Alright, so the next thing I want to do is to connect the amplifier. So this is how it looks like. It's not the most elegant way of connections, but this is what I have. And I'm going to turn on that amplifier, 12 volts. And I'm going to run the measurements. So as you can see, it's actually sweeping through right now step by step, and then we're going to do an auto scale so that we can see how it looks like on both sides. So as you can see, this is a midpoint, and this is where it happens. And yes, minus 3.8 dB noise figure sounds like it's impossible. So I asked ChatGPT, and this is what ChatGPT answered. Could be that our noise source is way too high. It's a 20 dB noise source, and our amplifier might contribute less than that. So hence we're getting this. So one way that I normally double check is to use an attenuator, a known value attenuator like 20 dB. Close to the noise source. So once you plug in, you get a reasonable 20 dB noise figure. So I know that my system is correct, and whatever is measuring, it does make sense. Please leave a comment if you disagree with this, and I'll try to find the good cause for that. So let's bear that in mind. I'm going to screenshot this, and so that we can do a comparison later. Alright, so I'm going to pause this now. Let's make it the proper way. Let's screenshot this picture so that we can recall that later. So this is noise figure measurements, and today is 2904 24 FieldFox. Done. Alright, while we are here, the same setup, let's put attenuator, a known value, so that we see whether our system is correct. So I'm going to power down that amplifier, and then remove the amplifier as the device on the task. And I'm going to put in the attenuator, 20 dB attenuator. So this is my current setup with the attenuator right in the middle. And I know this is not an elegant way of doing it, but a lot of you might cringe when seeing this. Me too. But this is what we have right now. And I'm still letting it run right now. Let's do a scale, auto scales. And if you notice, those blue dot is actually updated dot, and the pink color is the previous measurements. So I have a 20 dB hat, so it gives about 19.6 dB, which is quite tally to the loss that we are seeing here. So I know that my system is correct. So whatever it tells me when I put an amplifier inside, then I know the reading is still valid. Let's move on to spectrum analyzer. Change the setup right now. So for spectrum analyzer, if you bought the noise figure options, you should see this at the back of the spectrum analyzer, where you can attach a BNC cable to connect to the noise source. So currently this is my setup. For calibrations, the BNC cable is connected to the noise source controller at the back of the spectrum analyzer. So let's preset this so that you are able to see what's going on. Let's make this smaller so that we can access here. So how do we get to noise figure? Let's click that, noise figure. Okay, so these default measurements up to 3 gig. So we're going to change that again. Start frequency 1.04 gig. Stop frequency 1.49. 1.49. 1.04 gig. So I don't change the number of points. Of course, you can change both on FieldFox or even the spectrum analyzer. So the next thing I want to do is to change the bandwidth, and we did use a 300K bandwidth here. So we'll just type 300 kilohertz. That's it actually. So that's for the setup. And the next thing again, you'll need to put in the ENR table. Just go to measurement setup, ENR. So make sure that turn off the measure table, because that's the measure table is generated by user. So this is where you key in the points on the table. And if you want to add in another one, just highlight this one, insert row below. Let's say we set it to 4 gig. And 4 gig is 20.08. As simple as that. So once you're happy with that, just close it. As you have seen the connections, I have the noise source connecting directly to the input of that spectrum analyzer, and I'll just do a calibrations. Let's do a calibrations here now. Just let it go through. So one thing good about spectrum analyzer is that it is auto range every time it scans through. Okay? And the next thing I want to do here is cal setup. So we have user cal and internal cal. So what we did just now was the internal cal. You can run a user cal also if you want to. Again, if you have a preamp in the path, then we do recommend to do that. So we can do a user cal. And I said something wrong just now. So in the setting calibrations, this calibrate is to run a user cal. So if you click on internal cal, it has not been done. So internal cal is just a direct noise source to the receiving port, and user cal is anything that's along that path. So in detail, we can look at the help file in explaining to you what is the difference between the two. Let's turn on the marker so that we can see it right in the middle of the screen. Back to the middle. So it's a direct path. So we don't expect to have a loss or much of the noise figure. So right now we can connect our amplifier in the middle. So this is how it looks like after the connections. Then you can see that the noise source is at the input of that amplifier, and the output is connecting to the spectrum analyzer. So I just need to turn on the amplifier right now and let the measurements do its magic. 2.04. It's pretty close to our measurement just now. It could be something I didn't tighten. So let's go to here, nice figure, and yeah. So 3.6, 2.9. So the pattern looks very similar, and as you can see that because of the gain difference, 54 and 56, that might be the one that contributes to the difference between two instruments. And again, to counter check that, I will put in a 20 dB pad, see whether the system is measuring correctly. Let's turn off the amplifier. Okay, this is how it looks like for the connections. And I have the noise source connecting directly to the spectrum analyzer through an attenuator. And if you remember, the reading on the FieldFox for this alternator is roughly about 90.6 and the loss is about 90.8. So it's very similar. There's something changed here, could be the matching to that port because I do have extra adapter to that. So anyhow, this is how you're going to set up for noise figure measurements on FieldFox and also compare it to a spectrum analyzer. So I hope this helped. Thanks for watching.